So I thought about the tech ingredient video that I had previously thought about, and I released. It's out there on YouTube, part 1, that is. I have a problem with it. While it is a coherenter, and while it is an oscillator, and while it is an amplifier, kind of, I guess. More because of the radiation style of that effect, creating basically a sound chamber, resonance chamber. I can turn some of the other electromagnetic radiation back into a hopefully. This is what we're hoping. This is what I'm hoping here. If I can get a mirror effect, I can get the right dome effect. If I can get the right concave effect, and then focusing, coherenting effect with the right, rings and slots, grooves, as it diffuses from the panel, and then it goes over to where the panel is for the solar panel, and then focuses through the slots, and then creates a polarizational effect, and then another polarizational effect which collapses those effects, creating waves. Point is, I was all over the place with it, but and grooves on the little bends that you bend inwards, so that way it tries to coherent itself a little bit more during its slot effect. That kind of a thing. But then those kinds of a thing and those kinds of a thing then produces more of this kind of a thing, and so you get kind of this kind of a thing, which kind of just diffuses itself like this kind of a thing. And then because of those things, you get kind of like a ding ding ding, kind of. But then as it goes down, and then you have this kind of a thing in the middle, then you have this kind of a thing from these things kind of interacting, and then it creates a sort of polarizational effect within this kind of a thing, and so it kind of intrapedically, or no, that's entangly. It's more of the entangly variety. It's not really entangling. There's no entanglement. Sorry, folks. But, it's still something. And if I could get it with the right, angled diagonal grooves and curves, then I'm able to create sort of a polarizational and amplitude wave directionality focuser with that. Kind of star shape as these shadows. I love shadows. Look, what did we use this again for? It was some mirror system. I think it was a James Webb. No, it wasn't a James Webb telescope. It was some other telescope that they were like, hey, we have this flower pattern, and then as a result, it focuses the shadow forward. It doesn't go and focus into a beam. It continues moving forward, in a straight pattern. What I've learned is that if you do that the right way, you get a very similar effect for the beam inside. That tends to collapse and amplitude wave itself towards the given direction of travel for the majority of your electromagnetic radiation. I can see it in my brain. I don't know how others learned about this. I just happen to know about it because I thought about it real hard. Anyways, it's not as efficient as I would like. In fact, I'm kind of getting pissed off at it. I'm not kidding. It's like, oh, super cool. It from my estimations of what I can see in my head, which I get. Not everybody's gonna believe that, and I don't really give a fuck most of the time. If you were to practice and do it, unlike me, who's a broke ass motherfucker who actually doesn't have an income, and uses government programs to even be able to have like internet and cell phones. Obama stuff. Thank you, Obama. That's how I'm able to do this. But you don't need to know about that. Why the fuck do you give a fuck? Weirdos needing to know everything about my life. It's freaking paranoid creepazoids every time. Anyways, I wanted to talk about the fact that it's good enough to drop a 60 to a 40 degrees Celsius. And then there's a saturation effect and it climbs back up to 60, which is a problem. So it'll drop it down and then it'll slowly climb up because it has that resonance chamber, which of course initializes the panel to continue its heating up. And so it's a Stirling effect runaway thermal problem with light. Even though one area is for sure where it's going to come out, the other, it's not. And so, wonderful idea and concept as a light-based, I guess, electromagnetic radiation propulsion device, I suppose, at that point. If you could get it to push, because if it's the right frequency, you would probably get it to push the mass and accelerate it for very low amounts of energy. So there would be that. But, of course, the other side is very warm, and that's not what I'm looking for. So I ended up realizing a mistake in my initial design, and so now I'm like, oh, you know what? This is easy to again, make turn into a very simplistic design that still works. By creating holes that have that little flower pattern I was talking about, so it directs itself outwards in between each one of the panels, the cells of the solar panel, and then in that slotted groove, you create effectively another slot, but not quite a slot. It's more like a wavy slot. You want a wave style that allows for this kind of a trailing edge effect, so it diffuses itself. So as it waves, that means it's unlikely to interact with itself as it continues outwards. The light wave, that is, will unlikely that is, it'll be unlikely to interact and cause a reflectivity diffusal, and so it creates a pressure on itself, and so like that slowly causes it to spread out. But when you do that, like sort of this curve out, style, and then this wavy guide, you end up creating a very simplistic directionality. It's still going to diffuse, just a little less quickly. And it does so with these little holes that are in the in-between of the cells, where that will be very, very still coning out slowly, but a lot less. And it interacts with those wave-guided here IR energy, freaking fruit fly, electromagnetic radiation that allows for it to, again, do that amplificatory effect. And so it will collapse it inwards. And so instead of diffusing outwards, it collapses inwards, and then it's not coherent at all, but it's a much straighter beam forward. And we're releasing that light pressure. But in doing so, it's a good way to put this. in a way that allows for it to release more of the heat, as air will go over these holes and allow for air to pass through a little bit through that little slotted and kind of heat sinky design that is, of course, the resonance chamber and everything else for the coherency, polarizational, and focusing chamber. And that works really rather well, but then in that resonance chamber, there's another nice design as well on the sides where you allow for a angle. Okay, so an angle reflectivity to the pieces that, of course, still need the slots and grooves to effectively create the polarizational reflectivity. And so air will be allowed to pass through it on one side, out the other, but also from the sides up, also helping cool with like a heatsink, but it also reflects a lot of IR with the aluminum that is being used here. Anyways, that allows for a little bit of a light to escape, but a good amount of it's still trapped, and in fact it's still being diffused and focused majority-wise towards this steel sheet that is really just a heatsink. It's just a heatsink. It's just a heatsink. I'm not trying to be fancy and say it's nothing other than this quantum crazy blah blah blah. No, it's a heatsink. I have a heatsink. It's a light-based pump system, effectively, for infrared radiation that creates a heatsink effect as air convects off, and then of course it uses the Bernoulli's principle, which is of course as air is, because we have the reflective aluminum side panel and then a cone at the bottom and then, a cone at the top. It creates, with little slots at the top, it creates a rushing effect as air is traveling up, sucking in more air, concentrating it, which is what we're hoping to do. And then it creates the increased amount of air, which actually reduces the air pressure above, thus creating a larger effect of a suctioning convective effect, thermosiphon sort of style, which is a rather efficient method of utilizing light to pump heat away from a solar panel with minimal material. You just happen to need to know the correct groove slots, placements, and setting up with the correct resonance size chamber and the coherenter and amplitude, wave frequency. I don't even know what the hell they use for those words. To me, it's like it just combines. I don't know why they just say it combines. It's an amplitude creator. It amplifies the light by making diffuse light go in a particular direction, amplifying its wave frequency amplitude. But the wave frequency is still the same. It just has more energy, and it's stored also as a polarizational energy that likes to collapse when it hits the steel, which all you need for that steel is to spray paint it black, so that way it absorbs your light. Really pretty simplistic design. Steel is a great conductor of IR. It absorbs it very efficiently, and when it does, it also happens to elicit that, when it's thin like that, heatsink effect. Infrared loves to reflect off of aluminum, but not steel. And you paint it black, it really doesn't like to allow for the infrared to pass through. And so it will get warmer. And that's all you really necessarily need to do to make that work. and then I was like, oh, right, you know what? This one isn't as cheap as that might be, even though it's more of an arts and crafts kind of project at that point, because you kind of need to really know your grooves, your slots. You need to do the math to know the placement, the right angle bend, and so on and so forth. Which, hey, have fun. It's the cheapest method for the least amount material, and the increased cooling capacity that you achieve and gain as a result of this actually adds to itself the more solar panels you have in series, because you can really just make a big old, sheet steel thing that they all concentrate to, and it's going to be hotter. As a result of it being hotter, it pulls more of the heat away faster. And you can always have a weather vane system that happens to capture air moving in and then sucks it through faster, should there be any air for you to use this for, and then you can always just close it off if you want it to gain a little bit of heat during the colder months. Because it's freezing or something. I don't know what you would do that for, but if you so chose, you have the option. Okay, now we're going to move on to the fact that while super wonderful, cheap, easy to make, pump them out fast. Once you get the design right, once you get the right size, if it's a rectangle this size, and then plop this in, plop that there, clasp it together, and Bob's your uncle. You just drill here, and when really you drill here, you don't really drill here. You get out this tool, smack it with a hammer, bends it the right way, and you're done. You're good to go. And so you won't need to really worry about it. But, and this is crucial, if you can vibrate that damn fucker for the solar panel, and then put a thermal siphon, and I mean that like a legitimately simplistic thermosiphon, angle the tubes up, and then allow for the tubes to be facing whatever kind of diagonal way that you need for the wind to convect, and then have your heat sink fins to allow for the convection of your heat energy from a larger tube back to a smaller tube, and then utilizing a little bit of heat energy to rotationally spin, and then add to it any wind energy to allow for a pump to be actively doing this. Even if there's not enough heat, you should still be able to gain a massive advantage that it would easily be able to rival your standard styles of heatsink and fan combos. So it would work out rather well. I think that either one of those designs wouldn't be too expensive. Vibrating oscillators aren't very expensive, and if you have a significant other that broke particular devices, you probably have some around. You just need a board and some programming. Yes, I went there. And that's pretty simplistic and easy to do, but that's mostly because a rectangle happens to have very obvious resonant frequencies. It's the material design stiffness that you need to test, and the averaging of that allows for you to use the vibrational concentration of heat, which is not impossible to do. Another effect is actually a field effect style of heat capture and concentration. Okay, so we're going to talk about MOSFETs real quick, which use an electromagnetic field to drop resistance in a given line that allow for more current, amp, volts, whatever, to pass through the transistor. Okay? Now, if you decide to do something because it's a field effect that happens to allow the electron to pass through. Electron movement creates an electromagnetic field, which is a very real thing. Look at the Furbs. The Furbs is here. She says hello. She always paws at me whenever I'm talking to the camera. And then it becomes annoying because then whenever I try and scratch her and pet her, she runs away. So that's fun. Now, you're not allowed on the table. Definitely not allowed on the table. All right. Now, by utilizing a electromagnetic heating, resistive heating, you're able to make a design that uses a capacitive design. And so that electricity, upon being elicited here, because it's heat, we're going to use the heating and electromagnetic resistance to create a capacitor, which will drop its load into a collective electrical conduit and then add itself to the line. That is your DC line output for your solar panel. And then all you reasonably will have to do, because this actually forces a collapse of the electromagnetics, that is, the field, to be smaller and smaller. Okay, so and we're using up the energy. And so as a result, it's able to stay colder from that reduction of energy elicitation, electromagnetic field elicitation. But it's still going to get warmer, and so good old hey, so no, your memes here is effectively slap the roof of this car, this bad boy can hold so much, which is a real thing. Stop going after the freaking cable. Jesus Christ, Furby. Anyways, some of you might already know what I'm going to say as a result of that meme I just did. Some of you do not. Okay, now I do, and what it effectively means is we have something that spins. Okay, that's what that means. It has a lot of spin. There's a large degree of electromagnetic spin here occurring, as that is kinetic energy vibration. It's a quantum effect. Okay, now a good way to talk about this is on the back of the solar cells and on the sides, you're going to basically create a series of coils, but not really coils. Okay, it's a good way to put this, because you're trying to transfer a spin effect, a kinetic spin effect. It's a potential energy that's being done, an exothermic potential energy, into the piezoelectric spin effect, which is a compression torsional effect. And so these coils will be attached to a piezoelectric flat piece that has a suspension of springs. But these springs and strings are going to be held across the solar cells here at various drilled in holes, and then they're going to be suspended upon in between, and then that spring and then coil creates a capacitive resistance that allows for a oscillative effect. The spring and the piezoelectric piece, the flat sheet here, torsions itself accordingly and flexes, creating electricity. And so it's a quantum effect in the sense that it's a kinetic to spin, effectively. It's creating a spin, and then that gives us a which, if you're unaware, is also something that because it's piezoelectric, it's going to create electricity, sure, but that's not what I'm looking for. Piezoelectrical flat sheets also have a wonderful effect where when they are given electricity, they create their own flexing. But when they are using that electricity to allow for itself to go into where those little lines are, okay, in the solar cell, it then makes it such that the electricity cancels out as a amplitude wave is going down. Okay, so like a DC current is traveling down the okay. Or up, depending on how you want to look. I'm looking at it like the line is traveling down where the transistor is, so it has an amplitude and it goes down. Now, upon going down, we're creating a directionality of spin, which elicits our electromagnetic field. But when you happen to hit it with that electromagnetics, which of course is going to create that from that torsional, we're taking a resonance frequency, we're creating electricity, and then we're utilizing a, forget what the hell it's called. There's a material that takes electricity, and then it brings it over to the hot side and then the cold side, and so like it separates it. But we're going to be utilizing a quantum field effect with the piezoelectric. So give me a second. So it creates a capacitor which isn't a capacitor for your information right now, and I'm about to tell you why it is. As the potential energy loss is there's a vacuum of energy where the electron was created and the current is going through. As the piezoelectric oscillation creates a gain of electricity, it creates a potential difference between where there used to be an electron that is now trying to effectively create another one, and this electron basically charge, and then it jumps over to where that was and then helps it create that, and it basically stabilizes the kinetic potential into, instead of kinetic potential, we are gaining a quantum spin effect on the where you dumped your capacitor into this, as it creates a electromagnetic field which jumps the electrons even more in the transistor that is the solar panel or resistor or whatever, and it fires a increased amount of electricity through it, and so it reduces electron to kinetic potential into electron creation, which is a spin effect. It's a very well-known spin effect that has to be used that way. But you're using a mechanical design instead of a field effect design. A mechanical oscillative capacitor design. Now, does it effectively create a maximum or beyond maximum effect for your solar panel? No, it doesn't. There is no such thing. But what it does do is it harvests heat energy into electron energy, like a supercharger for your solar cell, and also only needing so much of that electricity, the rest of it gets dumped back into your lines. And so now you have a cooler that produces electricity for you, like a Stirling piezoelectric spin effect. It's a quantum effect. There you go. Bye. Have fun creating it if you ever so choose. It's my design. It's a Lemke design.